Most people think software is just code, but code is just only one brick. System design is the entire building plan. In this course, I will teach you how real systems like Instagram, Amazon, or WhatsApp are designed, even if you are not great at coding yet. So, without further ado, let's get started. What is meant by system design? So, system design is planning how a system works before building it. Think of building a house. You don't start by placing bricks randomly. First, you decide where rooms go, how electricity flow, where water comes from, how strong the structure needs to be. System design does the same thing for software. It decides what parts the system will have, how those parts talk to each other, where data is stored, how the system grows when user increases. It's not about writing code, it's about deciding how everything fits together. Why is system design used? Because bad planning breaks good codes. It's as simple as that. You can have perfect code, but if too many users come at once, or data is stored poorly, or one small failure crashes everything, the system fails. So system design helps us to handle millions of users, make system fast and reliable, or reduce cost and avoid future rewrites. So in short, system design prevent chaos at scale. Does system design needs coding? No. In most system design interview or discussion, you don't write code. You draw boxes. You explain how. You make decisions. You answer questions like where should data live? What happens if one server dies? How do we scale from 1,000 to million users? Coding comes after design. Design is thinking and coding is execution. Is the system design harder than DSA? Yes and no. System design is conceptually harder because there is no single correct answer. You must think in trade offs, and real world constraints matter. But system design interviews are often easier to clear than the DSA because you are judged on thinking and not tricks. Communication matters more than speed, and partial answers still score points. DSA tests memory and practice, and system design tests understanding. What are the different types of system design? There are mainly two types beginners should know, and that is high level design and low level design. The high level design is the big picture, what component exist, how services connect, and overall architecture. For example, user to application to server to database. We will discuss more about it in future videos. And the second one is low level design. This is the inside view, how each component works, data models, API, classes, and logic. So, in this course, we will start with high level design and then slowly move deeper. You might have heard something like, what are the seven pillars of system design? What are these? Every good system balances these seven core pillars. Scalability, like can it handle growth? Performance, is it first? Reliability, does it work consistently? Availability, is it always accessible? Consistency, is data correct everywhere? Security, is data protected? Cost, can we afford it? Every design decision affects at least one of these. So, these are the seven pillars of system design. What's the future of system design? System design is becoming more important and not less. Modern systems are distributed, cloud-based, used globally, always online. So system designs are no longer static diagrams; they are living system that evolves with user. So in future, engineer who can design systems will lead teams. Architecture thinking will matter more than syntax. System design will separate juniors from seniors. Will design be replaced by AI? No. So this is the most common asked question that I get is no. AI can suggest architecture, generate diagrams, or automate repetitive work, but AI cannot understand business trade offs, make judgment calls, or own responsibility when system fails. AI is tool. Design thinking remains human. Suppose you have ever made an app or even thought about this question, this really matters than definition that we have read till now. So, like, how does data move from user to server? What happens when traffic suddenly spikes? Why cannot we put everything in one server? How does companies handle failures without a user noticing? Why do systems become slow over time? What trade-off am I making with each system design choices? This course will answer all of this step by step in future videos. So do check out my other videos as well. You don't need advanced coding, years of experience, or fancy diagrams. You need clear thinking. In this course, I will teach system design from zero using real world examples in simple language. By the end, you won't Just understand system. You will think like a system designer. That's it for today. See you in my next video. Peace out.